Hi, today we'll discuss the homework question that I gave you in previous class and we'll discuss some assertion reason questions. Let's start with the homework question. The question was find the equivalent fraction of 8 by 17 whose numerator and denominator values add up to 100. Here they are saying we have to find the equivalent fraction of 8 by 17. That fraction whose numerator and denominator add up to 100. So, to find the equivalent fraction, we should multiply the numerator and denominator by the same number. So, here we'll let the same number be n. n. So, here 8 by 17 will be 8n by 17n. Because we are multiplying the numerator and denominator by n. So, it will be 8n by 17n. And here they are saying the numerator and denominator add up to 100. So, here we can frame an equation that 8n 8n plus 17n is equal to 100. So 17n plus 8n is equal to 25n. So it will be 25n is equal to 100. Here 25 is in multiplication with n. We'll transpose 25 that side and it will be in division with 100. So it will be equal to 100 by 25. Here we'll simplify this fraction by 25. 25 1 25, 25 4 100. So here we can imply that n is equal to 4. Now we'll put the value of n in this expression, which is 8n by 17n. So here it will be 8 multiply 4 by 17 multiply 4. So it will be 8 4 is 32. 8 4 is 32 by 17 4 is 68. So an equivalent fraction of 8 by 17 and whose numerator and denominator values add up to 100 is 32 by 68. So the answer of the homework question, 44th question, is 32 by 68. Now let's practice some assertion reason questions. For all these questions, there are some 4 options. I will read out all the options. First option, if both statement 1 and statement 2 are true and statement 2 is the correct explanation of statement 1. Second option, if both statement 1 and statement 2 are true but statement 2 is not the correct explanation of statement 1. Third option, statement 1 is true and statement 2 is false. Fourth option, if statement 1 is false and statement 2 is true. Now, based on these options, we'll solve the questions. Let's start with the first question. We'll examine statement 1. If 25 chocolates were equally distributed among 5 children, then fraction of chocolates received by each child is 1 by 5. Here they are not saying chocolates. Here they are saying fraction of chocolates, not chocolates. It is fraction of chocolates. Now, first let's calculate. First of all, to find the fraction of chocolates, we'll calculate the number of chocolates distributed. So for that, we will divide the total number of chocolates by the total number of children. So it will be 25 by 5. So it will be 5. So there are 5 chocolates distributed to each child. Here this is the number of chocolates, not the fraction of chocolates. It is the number of chocolates. So to find a fraction, we have to do the part taken or considered by the total part. So here we are taking 5 chocolates for each children and there are totally 25. So we will keep 25. So 5 by 25 can be simplified by 5. So it will be 5 1s are 5, 5 5s are 25. So here the fraction of chocolates distributed to each child will be 1 by 5. And statement 1 is also saying this. So statement 1 is correct. Now let's see statement 2. Here they are saying in statement 2, fraction is equal to number of items considered by total number of items. This is true because in a fraction, in the numerator, we take the number of items considered, and in the denominator, we take the total number of items or things. So here statement 2 is true. And here statement 2 is also the correct explanation of statement 1. So the correct answer of question 1 is option A, which is if both statement 1 and statement 2 are true, and statement 2 is the correct explanation of statement 1. Now let's jump on to the next question. Statement 1. Every proper fraction lies between 0 and 1 on the number line. Here they are saying that every proper fraction lies between 0 and 1 on the number line. A proper fraction is always smaller than 1 but bigger than 0. So here proper fraction will obviously lie between 0 and 1. So here statement 1 is correct. Statement 2. In an improper fraction, the numerator is always greater than the denominator. Statement 2. In an improper fraction, the numerator is always greater than the denominator. This is true because in an improper fraction, it is always greater than 1. So, to be it greater than 1, the numerator should be greater than the denominator. So, here statement 2 is correct. But statement 2 is not the correct explanation of statement 1. So, the correct answer of question 2 is option B, which is if both statement 1 and statement 2 are true, but statement 2 is not the correct explanation of statement 1. Let's jump on to the next question. Statement 1. Every fraction can be shown on the number line to the right of 0. To the right of 0, there are only positive fractions or numbers. But in the context of every fraction, they are saying positive fractions and negative fractions. So, but to the right of 0, there are only positive fractions. So, statement 1 is wrong. Statement 2. All the improper fractions except 1 lie to the right of 1 on the number line. In improper fractions, the numerator is greater than the denominator. So, obviously, it will lie to the right of 1. So, statement 2 is true. So, the answer of question 3 is option D, which is statement 1 is false and statement 2 is true. Now, let's jump on to the next question. Statement 1. 15 by 11 is a mixed fraction. False. It is an improper fraction because here the numerator is greater than the denominator. So, statement 1 is false. Statement 2. The fractional part of a mixed fraction is always a proper fraction. Here, let's imagine if the fractional part of a mixed fraction was an improper fraction. The improper fraction, the fractional part of the mixed fraction, if that would improper, then that improper fraction can be again converted into a mixed fraction. But when it happens, that fraction will not remain a mixed fraction. Here, statement 2 is correct. So, the correct answer of question 4 is option D, which is statement 1 is false and statement 2 is true. Let's jump on to the next question. Statement 1. 2 by 3 and 4 by 6 are equivalent fractions. First, we'll write these fractions. 2 by 3 and 4 by 6. Here, they are saying that these fractions are equivalent fractions. Let's see. Here, we are multiplying the numerator by 2 to get 4. So, we will multiply it by 2. So, 2 multiplied 2 is equal to 4. So, they are saying equivalent fractions. And if they're equivalent fractions, the numerator and denominator has to be multiplied by the same number. So, we'll multiply the denominator by 2 also. So, let's multiply denominator by 2. So, 3 multiplied 2 is 6. So, here we can say that 2 by 3 and 4 by 6 are equivalent fractions. So, your statement 1 is correct. Statement 2. To find equivalent fractions, the given fraction can be multiplied by itself. This is wrong. Let me give you an example. Here, we'll consider the fraction 2 by 3. Here, we are multiplying the fraction by itself. That means we are multiplying 2 by 3 multiplied 2 by 3. This is not an equivalent fraction because we are multiplying the numerator by a different number and the denominator by a different number. In equivalent fractions, we have to multiply the numerator and denominator by the same number. So statement 2 is false. So the correct answer of question 5 is option C, which is if statement 1 is true but statement 2 is false. Let's jump on to the next question. Statement 1. In 8 by 12 is equal to, here we have to find the value of this box. We have to find the value of this box. And in the denominator of the other fraction, they have given 48. So here they are saying 8 by 12 is equal to other fraction they have given, and of the other fraction they have given the denominator. We have to find the numerator of the other fraction. And they are saying the numerator is 32. That means this missing value is 32. Let's verify it. First we'll write it. 8 by 12 is equal to, here we put box, by 48. And here they are saying by this equal sign that these both are equivalent fractions. So here they have multiplied the denominator by 4, because 12 multiplied 4 is equal to 48. Right here, 12 multiplied 4 is equal to 48. They are saying that these are equivalent fractions. So to find a numerator, we have to also multiply the numerator by 4. So we'll multiply the numerator by 4. So here 8 multiplied 4 is equal to 32. And here also they are saying the missing value is 32. So here statement 1 is correct. Statement 2. To find equivalent fractions, both numerator and denominator are multiplied or divided by the same non-zero numbers. Here statement 2 is true, because to find equivalent fractions we have to multiply the numerator and denominator by the same number. And here in statement 2 they are saying that. So statement 2 is also true. And here statement 2 is the correct explanation of statement 1. So the correct answer of question 6 is option A, which is if both statement 1 and statement 2 are true, and statement 2 is the correct explanation of statement 1. Next question. Statement 1. 41 by 81 cannot be reduced further. Statement 1 is true, because we cannot simplify 41 by 81 with any same number in the numerator and denominator. So statement 1 is correct. Statement 2. A fraction is in its simplest form if both numerator and denominator are less than 10. This is false, because here we have an example that numerator and denominator are more than 10, and this is already in its simplified form. So from here statement 2 is wrong. So the correct answer of question 7 is option C, which is if statement 1 is true but statement 2 is false. Let's jump on to the next question. Statement 1. The simplest form of 32 by 28 is 16 by 14. Here we can simplify 16 by 14 further. Then further, most simplified form of 16 by 14 is 8 by 7, because here we are simplified by 2. 2 is the 16 and 2 7 is the 14. So the simplified form of 32 by 28 is 8 by 7, not 16 by 14. So statement 1 is false. Statement 2. A fraction is in its simplest form if the numerator and denominator are co-prime. Statement 2 is true, because a fraction is in its simplest form when the HCF of numerator and denominator is 1. And here in co-prime numbers, the HCF of those two numbers is 1. So here statement 2 is correct. So the correct answer of question 8 is option D, which is if statement 1 is false and statement 2 is true. Ninth question. Statement 1. 17 by 19 and 19 by 19 are like fractions. Statement 1 is true, because in like fractions the denominator should be same, and here the denominator is same, 19 and 19. So statement 1 is correct. Statement 2. Fractions with the same denominators are called like fractions. This is true, because when the denominator is same they are called like fractions. And the statement 2 is the correct explanation of statement 1. So the correct answer of question 9 is option A, which is if both statement 1 and statement 2 are true, and statement 2 is the correct explanation of statement 1. Last question. Statement 1. Here they are saying that 6 1 by 4 plus 4 1 by 6 is equal to 10 1 by 10. First we should add the whole part. So 6 plus 4 is equal to 10. Now we'll add the fractions. So here 1 by 4 plus 1 by 6. Here the denominators are not same and these are called unlike fractions. We have to make these like fractions by taking their LCM. Here LCM is 12. So it will be by 12. So we are multiplying 4 multiplied 3 is equal to 12. So we will multiply the numerator by 3 also. So it will be 3 plus we are multiplying 6. We are multiplying the denominator by 2 to get 12. So we will multiply the numerator also. So it will be 3 plus. So here it will be 5 by 12. And here they are saying that the answer is 10 1 by 10. Here we can say that statement 1 is wrong. Statement 2. Sum of two unlike fractions can be done by converting them into like fractions. This is true because here we just did this method. Here these are unlike fractions. We converted these into like fractions by taking their LCM and then added it. So statement 2 is true. So the correct answer of question 10 is option D, which is if statement 1 is false and statement 2 is true. That's all for this video. Thanks for watching.